Alright, welcome. So today we're going to do our video. This should be for Tuesday, January 24th. Let's take a look at our schedule for the week. So here's how everything's going to look. If you guys didn't know, I do have COVID. I got it over the weekend, so we're going to try to do this. I did this once in college with this sort of setup with the webcam and then the slides and stuff like that. I kind of like it, so we'll see how this turns out and you guys like it. So Monday, our assignment was that the problems were due. I'm going to extend that to tomorrow night because a lot of guys didn't have them in. I think I only have like 6 to 8 of them right now. I don't like almost 40. So Tuesday, you should be watching this video. There will be problems to do for the rest of the class, and then turn in your problems that are due Monday night. On Wednesday, those problems from Tuesday. So when you're watching this video, there's going to be problems up on Google Classroom. You're going to turn those in Wednesday night. Same thing. You're going to take a picture, you'll upload it to Google Classroom. I'll grade it, put in your grade, that sort of thing. Thursday is going to be a video, and like this one, and then Friday is going to be the same thing as Wednesday. There's a small chance I might be able to come back on Thursday. I need to talk with Mr. Finelli and some doctors to see what's up there. So we're just going to go as if this is the schedule and move on with life. So let's look at some terms. So I think my cam is covering up some things, so I'll move it later. So today we're going to be talking about isosceles triangles and then equilateral triangles, but we'll get to the equilateral later. So isosceles is a triangle that has two sides of equal length. You can see, just put this up here now. So we have a picture of an isosceles triangle on the right. We see that you have two sides of equal length, those two legs. And the legs are going to be the congruent sides of the isosceles triangle. The base here at the bottom is going to be essentially the other side. So even if the triangle, like normally isosceles triangles are always going to look like this. They're always going to kind of sit, and like down here is going to be the base, and these two are going to be your what's called your congruent sides. But what happens if it appears like this? That's why the base isn't always just like the bottom part. It's the third side, the other side. The triangle is, slanted like this. It kind of removes that sort of discrepancy. This vertex angle is going to be the where the congruent legs meet. So obviously on the picture on the right, it's that top angle because the two congruent legs meet, and then they form the angle up top here. That is going to be what's called our vertex angle. And then lastly, our base angles are just the other two angles, and those are going to be across from our legs. And then lastly, I put this note about what a corollary is. So it's basically a theorem that can be proved using another theorem. So usually theorems are something that's proved with postulates, and postulates are things that are assumed to be true because no one can prove them false otherwise. Corollary is just, it's a term that's used in a book. I will almost never use it, but I know a lot of the math world does. So I wanted to introduce you to that. Now let's look at the isosceles triangle theorem. Let's put the cam back up here. So this states that if we have two sides of a triangle that are congruent, so we have a side here and a side to the right, then the angles opposite of those sides are also congruent. So this is something that you can prove. Well, don't prove it in this video, but it is on 251 if you would like to take a look. I'm going to leave that up to you to look at, and then also pause the video if you need to catch up on notes. I'm just going to keep going through because I have a time limit on how long I can use this for all this software, so we're going to keep going. So now we have what's called the converse of the isosceles triangle theorem. So this basically says if we have those two base angles that are congruent, then the opposite sides are going to be congruent. So we have this triangle ABC. If we have angle ABC, or and ACB congruent, then we have those sides are congruent. It's pretty much just the same thing backwards. That's why we use the converse. If you thought back to when we were talking about parallel lines and alternate interior angles, we had the alternate interior angle theorem, and then we also had the converse of the alternate interior angle theorem. Same thing here. It's just kind of like you're using one thing to prove one thing, but the reverse is also true. So we have another theorem about that. Next up, we have kind of this more or less, I wish I could shrink my camera, but I guess I can't. I'll just move this over. Oh, there we go. That's a little better. So we say if a line bisects the vertex angle of an isosceles triangle, then the line is also a perpendicular bisector of the base. So perpendicular bisector. So this just means it's a bisector, so it cuts that line in half, and it's perpendicular, so it's going to cut that line in half at a 90-degree angle. You could see in the bottom right image. I'm sorry about this. See in the bottom right image where CD intersects AB, we put the box, meaning it's perpendicular. So we're good to go there. So on the left, if we have that the two sides are congruent and the angles up top are congruent, then CD and AB are perpendicular to one another, and AD is congruent to BD, meaning it's a perpendicular bisector. So once again, pause the video if you need to take more of a look at this. There's a pretty much the same exact explanation and pictures on 252 if you'd like to look at that. Next, the equilateral triangle. So this, by definition, is a triangle with 3 congruent sides and 3 congruent interior angles. So if you have your 3 angles being congruent, we can label them all as whatever. They're always going to be equal to 60 degrees, always. The reason why is the sum of the interior angles in any triangle is going to be 180. So if you divide that by, 3 congruent angles, you're going to get 60. Oh, excuse me. Thanks. Now we also know that those sides are going to be congruent, and that's the definition of equilateral triangle. And there's a few little notes that goes with this. Like I said, here we have an extended version of it on 252. Equilateral means sides. This should be of equal length. Equiangular means angles of equal measure. And then we also just have this note saying if a triangle is equilateral, then the triangle is equiangular, and if a triangle is equiangular, then the triangle is equilateral. They're generally known as equilateral triangles. So that's kind of how I will use them. And when we get into similarity, this is going to become a little bit more necessary. So I'll pause it or look in the book for the notes, and we'll move on with life. So, of course, I wouldn't let you escape without doing a proof. So we only have one today, and I want you to take a look at this. So I have that essentially the 2 outer sides of this triangle, or 3 triangles, or 5 triangles, however you want to look at it, are congruent, right? And then those 2 bottom segments, A, B, and C, D, are congruent. So I started out the proof. I wrote my statements, my reasons, and my givens. It actually took me a minute to think about this. So I want to prove that the ABE and DCE are congruent. So the triangles that are kind of like off on the right and left respectively. And I'm trying to think about this, and I'm like, oh, well, what ways can I prove, angles or triangles, are congruent? So I'm thinking, well, I already have 2 sides. So I either need side, 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 or I need side, angle, side. Because remember, angle, side, side, no good. No good. No ass. No good. Can't use that. So I'm looking at this a little bit more, and I'm like, I really don't see any way, shape, or form that I could use anything in my knowledge to get side BE or side CE. So this part or that part, I don't know if you guys can see my mouse, but it is what it is. If you can, you can. If you can, you can. Cool. So then I was like, okay, well, we just had a section on isosceles triangles, so let me see if I could use that. And it turns out that if we think about the huge triangle, the short, fat, really wide triangle, AED, the huge one, I have two congruent sides. When I have two congruent sides, I know that those opposite angles are going to be congruent. So I can make this statement and reason that BAE, so the super bottom left angle, and CDE, the super bottom right angle, are going to be congruent through the isosceles triangle theorem. I'll read that out for you guys one more time. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So now I have that these two angles here are congruent, and I can use side angle side to go ahead and prove it. Okay? So that's going to be my last step. The two triangles are going to be congruent through side angle side. Yeah, so something that took even me a minute to go ahead and look at how to do. But using the facts that we just learned, we're good to go. Now, I know I'm not in the classroom, but I do still have relatively high expectations for you guys this week, especially up until Wednesday at the very least. I want you guys to do your best, work together, do your best to do the problems I'm going to post, use the book as a resource, use the internet as a resource, use this video, use these notes as a resource, okay? Do your best. If you're stuck, look back at the theorems and the stuff about isosceles and equilateral triangles that we're talking about today. Okay? Think back to, how we're going to prove triangles are congruent, because that's going to be necessary for some of the stuff in the homework. Okay? Just do your best. If you are uber stuck and, you're with your one buddy and then you go talk to another group and you can't figure it out, then email me. Okay? I feel relatively okay. I feel pretty decent, so go ahead and send me an email and I'll see what I can do for a response. So if you guys have any questions, let me know. If not, I hope you guys have a good day. And yeah, that's it. So have a good one.